Hello, and thank you very much for joining me today. It's Allan Laboucan with the Rocks and Stocks News website. I'm very bullish on copper. The problem that I have is finding a lot of good copper stories out there in the exploration space. And I found one in Bell Copper. And today we have Tim Marsh on to tell us about Bell Copper. Tim, thank you very much for joining me.
Thanks for interviewing me.
Oh, no problem. So I had a chance to look at your corporate presentation before the show, and I like the quote right on the front of the page. It says, "Poised for discovery in a land of giants." Why don't we get started there? Because we can start with why Arizona and then talk about what you're doing to have you poised for discovery.
Yeah, fantastic. One answer to that question, why Arizona, is it's one of the safest jurisdictions in the world to explore for copper. There's copper a lot of places. Arizona is a great place, very highly endowed with copper, and so is the Congo. And if you find something in the Congo, the chances of you getting to mine it and return something to your shareholders is pretty slim. Freeport McMoran got their tail whooped at Tinke Fungurume, and a lot of other people having a hard time getting anything done there. Arizona.
Now we're seeing a new president in Chile, which is another important place for copper. And it looks like he's going to create some issues for the miners there. And you guys are in Arizona where there's some monster deposits.
Yeah, it's terrifying what's happened in Chile. They'll be back to where things were in the late 70s, nationalization of the copper mines. Foreigners will be fleeing. We've already seen Codelco here in Arizona looking at all of the copper projects. They're here. They know they need to be looking other places than Chile. Again, Arizona's got a great copper endowment. If you look over history, 10% of the world's copper, the copper that's currently in existence inside of things that we use today, has come from the state of Arizona. It's probably on a per square kilometer basis the most richly endowed copper province in the world. Chile is a lot longer, but again, it's stretched over thousands of kilometers. Arizona is really packed with porphyry copper deposits, mainly from the Laramide era, and they've been mined here successfully and continuously for the past about 120 years. So it's a great place.
Why don't you tell us about some of the big mines and how they fit into the grand scheme of things? I mean, Chile's an important big mine place, so is the DRC. Where do the big mines in Arizona stack up?
They stack up very well. Morenci is probably one of the biggest. Ray in Arizona, one of the biggest. Miami, that whole district, they've been in operation for 120 years. They were the first big open pit copper mines in the U.S. Dan Jackling developed the idea of bulk mining of copper deposits up in Utah, and very quickly was doing the same thing here in Arizona. And the mines of their century lifespan resources. That's what Bell Copper is looking for. There are more of them here. 80% of the state of Arizona is covered with sand and gravel and post-mineral rocks, so you can't see the endowment that we have. Now, there's about 20% of the state that pokes up, and that's what the old timers found 120 years ago.
But the rocks are the same underneath the cover.
Yeah, that's right. Due to stretching that happened in the last 20 million years, much of the state of Arizona has sunk below the average ground level and is now under sand and gravel. And that's where Bell has chosen to explore, because we know the endowment isn't any different just because it's covered with sand and gravel. On average, the same density of mineral deposits ought to be present underneath these valleys, which constitute most of Arizona. And that's where we look, and we're having success.
Now, on the putting it into context again, these are mainly porphyry deposits?
That's right. There are some massive sulfide deposits in Arizona. They're with one notable exception. They're rather small, but it's the porphyry copper deposits that formed mainly about 60 to 70 million years ago, what's called the Laramide era of mountain building. That was when most of Arizona's copper arrived.
And what kind of grades are they in comparison to Chile or British Columbia or the DRC?
That's a loaded question in that what has happened early in the mining history of Arizona was that the supergene enriched caps on these deposits, the part that had been exposed to weathering and upgrading by oxidation, has enriched the copper. That's what the old timers got, and that's really what got bulk mining started in Arizona. That environment, that enrichment environment, is still present in deposits that haven't been discovered underneath the valleys, but it's been mined out a long time ago in Arizona, such that the current mined grades in some of these big Arizona open pits are down in the 0.2% copper range.
Where did they start?
Well,
What
they
kind of?
started at multiple percent, 2, 3, 4. Early in the 1920s, the cutoff grades were 5% copper.
Wow.
So compared to the amount of material that we move today, there wasn't a lot of that in tonnage wise, but the grades were spectacular. When we find something new, we can expect some of that sweetener to be at the top.
Okay, so you're from Arizona, right? You live in Arizona.
I have for about the past 26 years. I migrated here after graduate school, and I haven't left.
So I've heard you're kind of a well versed of the connoisseur of Arizona copper.
I know what it takes to do work here all seasons. The winters are fantastic. The summers it takes a little getting used to work around a drill or out staking claims in Arizona in the summertime, but I know how to get it done.
And the nice thing about being there is you can meet with the government and the local people and, shake some hands and stuff like that.
Yep, I know the regulators. I've worked cooperatively with them in the state. The state of Arizona itself controls a significant fraction of the lands in Arizona that are prospective for copper. And then the federal government owns another significant fraction. I also like exploring very much on private land. It gives you a lot of opportunity to get things done without interacting with a lot of federal regulators.
Gotcha. Okay, so now that's a pretty big situation. Arizona's land of the giants. We clearly established that. Now, the other part of your presentation says poised for discovery. So let's talk about your projects there and the work you've done and why you think you're poised for discovery in the land of giants.
We've got a common theme to our deposits. We're not blindly out under sand and gravel looking for new things. There are deposits that are exposed in the mountain ranges that expose a deep level of porphyry systems. And it's really just been the past 10 years maybe where the science of economic geology has begun to recognize the vertical zonation of porphyry copper deposits, how you can have a barren altered root zone underneath a metal endowed cap. And because of the way Arizona has been stretched and faulted.
For simple terms, is that because the fluids, they have a cap that allows them to circulate for long periods of time?
Yeah, it has to do with the heat distribution when magma comes into the earth. It's hot down deep and the tops are cooler. So the metal exits the hot rocks, migrates up into the cooler rocks, and eventually precipitates, just like the mineral deposits in your toilet or sink. They precipitate and form a crust on the walls of whatever fractures or conduit pipe they're flowing up, and the metal rich parts tend to rise up into the cooler parts of the system. So there's a barren zone underneath with it that's quite recognizable, and a metal endowed part up above. And that part that's up above, because of the way Arizona was stretched, ends up down in these valley bottoms.
But the mountains give you the indication of where to look under cover.
Exactly. That they are actually a place where we can put our boots on the ground. We can measure dimensions. We know the things that we have found in the mountains. Other geologists found them, but what we did that was probably unique was recognize them as the bottoms of porphyry copper deposits, no less prospective than the big producing mines, just a deeper exposure of the same kinds of things. And that if we could find those shallower parts post faulting out in the valley bottoms, we would find just what the old timers found in the mountain ranges for
up in the mountains.
Yeah,
right. I mean, that's not a unique model. We see the same thing in Nevada.
Yep.
You know, a lot of the mines are found in the exposed rock, but the rock continues underneath the cover.
The appreciation for how far some of these valleys have slid, how far the rocks are separated, is something we're at Bell Copper just really getting our heads around. The idea that things have slid or moved many kilometers, many being 10 to 13 kilometers, is something we're beginning to prove by putting that core into the box, correlating rocks over those sorts of distances and demonstrating that this idea is
valid.
Actually real. It's valid.
Okay, so in your case, are you able to use geophysics to see through the cover?
Yeah, we've had a lot of success now using magnetotellurics in particular to look for large volumes of deep rocks, relatively deep rocks, that are electrically conductive. Now, the source of that conductivity is a little controversial. It might be water associated with clay alteration. It might be sulfides themselves, which are electrically conductive. It may be groundwater that's been modified by the presence of sulfides in that volume, but it's pretty clear there are some amazing electrical conductors in the areas where our fault targeting would tell us, hey, go out and look there. And that's just what we've done this past year at Big Sandy. We've gone from a geological concept based on faulting and slip to a magnetotelluric anomaly out in the valley bottom to core in the box that said, hey, you got it.
So you've got the faulting that kind of opens things up, and now you're able to target better where to look for the deposits.
Exactly right.
Okay. So you have two key projects. Am I getting that correct, Tim?
Yeah, we only have two. We started with one and really demonstrated the concept there. That we used to call it Kaba. It's been renamed Perseverance. And for the past about 3 years, that has been under option to Cordoba Minerals. That's a company controlled largely by Robert Friedland. It's a public company. Their geologists saw our core in the box, and really, we had a joint venture with Rio Tinto on it before that. Again, they saw the core we were drilling. They said, "Hey, this has potential." They came out, ran geophysics, drilled some holes, and based on core that we recovered, the Friedland group got involved, and they've been pursuing it ever since. So they're spending their money on that, advancing that project.
So, I mean, just to put that into context, Robert Friedland doesn't look for small things.
Right.
He has to have the reality of what you see with the truth machine, and then the potential that it could be very big. Why don't you tell us a little bit about the option agreement?
And he knows the thing is big because we can see the bottom of it exposed in the mountain range west of our property.
Okay.
And, he flew into Kingman personally, climbed into my pickup, and we walked the root zone. And the root zone is really what tells the story. And it is the story you come away with is, I call it church. It's a place where I make believers out of people. And, he was baptized there, and he got he got the fire in his belly to see that this is really a big thing. It is an intensely mineralized and altered thing, and it's worth looking for.
And you know, another thing about Robert is that he has a very good nose for big deposits. He's found them in his career a couple times, a few times. And so he has a very good nose for especially early stage as well.
Yeah, he really does. He deserves an honorable diploma, honorary degree in economic geology.
Exactly.
He did more talking about what we saw back in the footwall than I did while we were there. He understood what he was saying. He appreciated, what the implications were, and he's got good people around. He absorbs what he hears from his experts around him very well.
It fits in there.
Yeah. So what they saw was the potential to find a globally significant porphyry copper deposit at Perseverance.
And how does the deal break down? What do they have to spend? What will you be left with? What's that deal?
Yeah, it's a staged earn-in over started a total of 8 years from initiation. They're now into their second phase of the earn-in. They spent $1 million finishing drilling the first hole and running magnetotellurics. They're now working on their second piece. Right now, they've got a 25% interest in the joint venture company that controls the asset. So right now it's Bell 75%, Corp Minerals 25%. They're well into earning their second piece, which is a 51% controlling interest in the joint venture company. And they've got until April of 2022 to finish that earn-in. The way they're drilling right now, they'll clear that easily.
How much do they have to spend to get to 51?
In total, it was about 3.5 million. They're probably less than $1 million away from clearing that hurdle now. And they've got drill on the property right now. There will probably be 2 in January. They'll clear it easily.
And do they have the option to go further?
Yeah, absolutely. Yeah, through 2 more phases, they can earn up to 80% of the project, leaving Bell a residual 20%. And to do that, they need to spend a total of 17.5 million Canadian to earn in. At that phase, we believe there will be enough information for the market to appreciate the value of our 20%. And
would you have a carried interest of the remaining 20, or would you be a participating partner at that point?
As soon as we declare a joint venture, we are a partner and we'll be responsible for our 20%.
But if they go to 80, you should be able to get your 20, no problem.
I believe we can. I'm confident.
Now, sometimes when dealing with those deep pocket groups, it can be a little challenging getting the news flow out of them. Do you have any, if anything in the agreement that, provides for you to have a flow of news?
Yeah, we've got the ability to, certainly the requirement, the exchange requires us to publish anything material. And that's whether it comes out of Perseverance or our other projects. So I'm obligated to release material information. We have had, discussions about what we ought to release, what we can release, what we must release in the past, and that hasn't been an issue. So I see in the future that when material information comes along, it will flow, immediately to the market, and we'll be able to communicate with our shareholders the value of what's being generated there at Perseverance.
So it sounds like from Perseverance, you could have a news flow for the next 6+ months.
Yeah, that at the rate the work is going, there will be news out of Perseverance regularly.
And I'm sure Robert would want to tell everybody about a new big discovery in Arizona.
Absolutely.
Okay. So then you've got your own, the other project is 100% owned, right?
Right. And it uses the same geological concept that got us out into the right spot in the gravel at Perseverance. 10, 11 years ago, it became clear the geologic concept was paying off. We were putting core in the box that confirmed we were out in roughly the right part of the valley and finding the things we expected to find. So we moved about 17 miles to the south and began exploring down there with exactly the same idea.
And that's called Big Sandy, right?
Called Big Sandy. Yeah, there's a porphyry root zone called Diamond Joe Peak that's been known for many decades. Porphyry geologists have gone there and drilled and tried to find an economic copper deposit, and they didn't. And my answer was they should have been drilling up rather than drilling down, because they were in the deep part of the system. The copper-rich shell would have been above their heads, somewhere up in the air. And that volume that used to be up in the air has been faulted down out into the valley, and now under sand and gravel in the middle of the valley. And that's where Bell has set up shop. We've gone from claim staking a year ago to a magnetotelluric anomaly, which showed a very large, very prominent conductor in a likely spot, and finally, starting October of 2020, drilling. And the hole number one cuts a short interval of chalcocite, chalcopyrite, quartz veins, molybdenite. We found porphyry from which we've separated zircons that have been dated to have exactly the same age as the root zone. So we've used geological tools to demonstrate the concept is right, and that's from data out of our core samples in our first hole, correlating that back to the footwall 13 kilometers away.
And it really, I'm just looking at your presentation right now, and you can, just looking at it from Google Earth, you can see the structural picture quite nicely.
That root zone is spectacular at Diamond Joe Peak. It's six kilometers in diameter. It's just a big bullseye with annular fractures, annular veins, radial veins, all culminating at the tip of Diamond Joe Peak, which is just a fascinating place to look around. That is the plumbing, the deep plumbing of a giant porphyry copper system. And Bell has found its correlative parts in the hanging wall of the fault, now way out under sand and gravel in the Big Sandy Valley.
Wow. Yeah, you can really see, it looks like there's a couple plugs in there that are like depressions.
Really spectacular.
Wow. And then I'm looking now at your geophysics. I mean, that's a massive geophysical anomaly.
Yeah, the central conductive rocks there have resistivities on the order of 10 to 15 ohm meters. To take a granitic rock that should be dry and have resistivities up in the 1,000 ohm meter resistivities, and to knock it down a couple orders of magnitude really takes a lot of alteration, mineralization, fracturing. There's got to be a lot of water in there. They're very conductive rocks, and it's a giant, compelling target that matches roughly the size and shape of that footwall root zone.
So, okay, so there you have a line 13.1 kilometers apart. And you can see the faulting going in that direction. So do you visualize that this would be the source in red, and then you're looking for the extension over in that 13 kilometers apart area?
That's it, exactly.
Well, you can see the faulting that goes right through the valley. Am I reading that correctly?
Well, anything that you see in the valley has to do with modern drainages, active drainages, lineation produced by drainage channels that are wetter than average and support some vegetation. So you don't see a direct correlation between.
No, but you see what should be where, based on that, you should see where the faulting is coming off the mountain, and then some indications that it continues.
That's exactly what we've done. we went out into that part of the valley after having drilled some encouraging holes back at Perseverance. As soon as we went out there and walked around, we began finding exotic copper, copper that had dissolved in groundwater and was squirting up faults in the gravel.
Wow.
So we have gravel that's cemented by black copper oxide called copper wad or neodicite. Evidence that groundwater is tapping something deep in the subsurface there, transporting dissolved copper up into the gravel and showing us kind of with free drill holes where that leak was. And that's where we've drilled our first 3 holes at Big Sandy.
So is the whole thing perspective from the red area all the way over to the point of where you have that 13 kilometers apart?
We've got a bit of drill data in the intervening open ground in between. And what's clear there is that the depth of gravel is quite significant. There was a hole drilled in the 1980s by the US Geological Survey, went to 5,000 feet with a big oil well style rig. And they never got out of gravel. So there can be some formidable accumulations of gravel in the bottom.
But so you're kind of looking at something like this.
Exactly. Yeah. It's an asymmetric graben, a little shallower on our side, the east side of the valley, than on the west, quite deep in the west. So we've skipped over that intervening ground and put the right core in the box.
In the eastern side.
The eastern side of the valley, right?
So you're looking for this side of it.
Yep, exactly.
Okay, so now let's talk about, you've done some drilling recently on Big Sandy?
That's right. We started drilling as soon as we got that magnetotelluric anomaly. I had already permitted some sites in that area. And late October, we got our drill out there, October 2020, and began drilling the first hole. By Christmas of 2020, we had our first porphyry intersection. I picked the zircons out of that porphyry over Christmas, sent them to University of Idaho, and got the same age as the footwall intrusion, the one you can see there on Google Earth.
So you know they're related.
We know they're the same age, statistically indistinguishable. It's permissible, not required, but permissible that they're exactly the same porphyry. We saw, quartz veins, molybdenite, chalcopyrite, all the sorts of minerals we went looking for with this model. They're down there in the subsurface. We didn't hit the guts of a porphyry copper system, but we very clearly hit a porphyry copper system. We think that particular hole is on the eastern edge of what we're looking for. We've since drilled.
But at that point, you didn't have the MT, right?
Yeah, we did. Yeah,
Okay.
Yeah, and we could see that we were on the northeast flank of that MT anomaly, but it suggests there are kilometers to the south and west of us that are very prospective. That's where the drill has gone.
That was the drilling in 2020, but you've
2020.
gotten some more recent drilling just a little while ago.
Right. The drilling hasn't stopped. These are fairly long holes through gravel, 1,000-meter holes. We drill through the gravel. As we get toward the bottom, the gravel gets redder and redder and redder. And we see more and more porphyry pieces in the gravel. And then we hit the bedrock. And once we're down in the bedrock, we see the things that you ought to see if you're in or near a porphyry copper deposit. Okay,
so before we wrap it up, let's talk a little bit about what is pending. Do you have some of those holes in the lab now?
Nothing, just the way I work. I don't send everything to the lab. I've got a handheld X-ray fluorescence spectrometer, so I know if something, hey, is this going to be ore? If it's not ore, I don't want to send it to the lab. I can see the molybdenum, I can see arsenic, lead, zinc, copper, other useful elements with that analyzer. I've got a real good eye that's been tuned to Arizona porphyry copper deposits. And so really, we run on the cheap at Bell, but we don't do things foolishly. But sending a lot of low grade or barren rocks to the lab for analysis isn't something I do.
Well, especially when you can learn enough from the XRF.
That's right. It's a powerful tool.
Yeah.
When we start drilling rocks that I'm pretty clear the market will appreciate, we'll cut them and get them into the lab as fast as they come out of the ground. We've got a saw on site, got a geo that's helping me out there. And this stuff will get into the lab, which is right here in Tucson, one of the world's best copper assay labs, Skyline Labs here in Tucson. They'll chew into that. And we think we can get 3 to 4 week turnaround.
Oh, beautiful. So ongoing drilling, you're looking for the right kind of stuff, then you'll start sending some stuff into the lab.
That's right. And based on what we're seeing and the current hole, that material will start flowing to the lab in the early weeks of January. That's my expectation.
Well, and I hope it's certainly not lost on me, Tim, about the eye, because I spent a lot of my career in diamond exploration. And, you have to look at diamond indicator minerals at the surface because the diamonds are so rare relative to the indicator minerals that are still sitting on the surface. And I worked with a guy who, he wasn't a geologist, but he was one of those guys with an excellent eye. And he could walk along a piece of ground and spot a tiny little indicator mineral just off of his eyeballs. And it was like, and he made an important discovery for a company that ended up finding a mine where he was spotting some of that good stuff. So it's certainly not lost on me how important a good eye is in mineral exploration.
It's one of the most powerful tools I've got.
Excellent. Excellent. Well, I think we've done a pretty darn good job of telling the Bell's story from for the investors out there. Was there anything you wanted to leave it on, Tim?
Well, in summary, we're in a great jurisdiction. We've been seeking out the largest types of deposits in the world, these big porphyries. We know they're big because we can see them back in the footwall, and we're putting the type of core that is associated with these deposits into the core box right now. All we have to do is keep that drill turning, and a discovery will result. That's my expectation.
Well, and you've certainly got all the indications. You can see it in the structural story. You can see it in the VTEM. You're getting a lot of things pointing you in the right direction in the land of elephants.
That's it.
Awesome. Tim, let me wrap it up, and then we can have a little talk on the other end.
Very good. Thank you for the opportunity to talk.
Well, I really appreciate it. So there you go, folks. I'm hugely bullish on copper. I mean, I think it's pretty apparent to people with the electrification of vehicles that we're going to need a lot more copper. I mean, I remember 10, 15 years ago, a report going out where they mentioned that just to meet the demand back then, this is before electric vehicles, we needed to find an Escondida practically on an annual basis. And just to meet the demands of the emerging economies and the developed economies, that has not happened. Now you bring on the electrical vehicle story. And the one thing that I do believe that I think everybody understands the electrical vehicle story. What I don't think they understand is the developed economies are working on power grids that are ancient. And in order to get the power to those electric vehicles, they're going to need to upgrade the existing power grids. And that can cause as much demand for copper as the electric vehicle revolution. So, and I think these things are inevitable. Practically every economy of the world is moving towards electric vehicles. There's a big push towards that. Consumers are pushing towards that. The economics are starting to get to the point where, they can provide vehicles at much lower cost than maybe 3 or 4 years ago. And every car company wants to be in the electric vehicle revolution. So the demand story is there. The supply story is not there. So more copper exploration needs to happen. But from my perspective as an analyst, looking for good stories, there's just not a lot of out there. Looking for these kind of deposits, and especially and then you try to look at areas that can find these big elephants. Chile's having problems. DRC is a problem. Arizona is like, go there, young man, kind of thing. And Tim and his team have done some great work. And it looks like they've got the potential for 2 important discoveries. As I always say, my shows are for information purposes only. It's important for you to do your homework, speak with your financial advisors, and really roll up your sleeves, because this company only has a $13 million valuation, and they're looking in the land of big deposits, and everything is pointing them in the right direction. So this is the time to take a look at a company like Bell Copper, and I invite you to do that homework. I've done it. I like what I see, and I'm really glad we had Tim on. So on that note, thank you very much for joining us, and we'll talk to you soon.